Welcome to the Extractive Distillation Simulation tutorial part 3. Till now we have discussed the Solvent Recovery Column, Extractive Distillation Column. Now if you remember the flow sheet, the only thing that is left to connect this solvent recovery back to the phenol, back to the input to the Extractive Distillation Column. So what I will do now, first I will put two property tables, one containing the toluene product, which is the toluene product, and I will include its temperature, molar fraction of the toluene here, and you will see molar fraction of the toluene is 0.98612. Now similarly I will do for the phenol solvent. For the phenol solvent, temperature and the molar fraction of phenol for the overall mixture. Now you see here the temperature of phenol is 158.24 degrees centigrade, but here the temperature, if I see, of this stream is 25 degrees centigrade. Now why I am saying this, here you will see for this stream the mass flow is almost 109 kg per hour, and this stream it is 100 kg per hour. So mass flow is almost same and the amount of phenol that we are getting is same, but here the temperature is 25 degrees C, while here the temperature is 158.246 degrees centigrade. So remember, if you see the flow sheet here, if I talk about the flow sheet, here you can see in this flow sheet the phenol is directly recycled back to the column. But what is important that these two streams should be at the same temperature, otherwise what will happen, as per the temperature the other product will be in a vapor phase, and then it will hence affect the equilibrium of the distillation column, and then for the same number of stage and reflux ratio I will not get the same purity of the components and distillation will be completely different. So to maintain this, what I will do, I will go here, I will choose a exchanger and use a cooler, and what this cooler will do, I will go to the cooler simulation, I will make it as a see the outlet stream. First I need to rename it outlet stream as a phenol recovery. Now you can see it is the phenol recovery. Now what I will do, this cooling temperature, what I will do, this cooler I will simulate it for the outlet temperature, and for the outlet temperature it should be 25 degrees C, which is same as of the phenol. Now what I will do, I will solve the flow sheet. Now you will see here the toluene product and the isooctane product purity should be same after the simulation ends, because this doesn't affect anyway anything. So now they are 0.99% pure isooctane and 0.986 which is closely 0.99% pure toluene product we had. So what I will do now, I will now use a logical block, that is a recycle block. Why I am using a logical block? To connect this stream back, because that's how we simulate in DWSIM. This recycle block will take care that whatever we are recycling in a continuous process. So what it will do, it will solve the equation coming in minus going out should equal to 0, and in that way it will iterate this flow sheet, change few parameters, and then make it as a steady state process. So all these equations are put in this recycle block as a logical block, and this will solve the non-linear equation for us. So what I will do, here I will put a recycle block, I will go here, inlet stream will be phenol recovery and outlet stream will be phenol. Now you will see there are two lines that are generated. Yes. Now what I will do, I will close all things And now my what will be the output of this simulation, or what will I call a success for this simulation? Once I click on the solve button, there should not be a significant change in the mole fraction of toluene and the mole fraction of isooctane in the top products, because these two streams are my separation product and they should be almost pure with the desired component. So now I will hit the solve button. Now you will see after a time this will be solved. Now here you can see it is 0.98612 and it is 0.990296. Now this is the complete flow sheet we have simulated in the DWSIM. This is how we make a complete flow sheet, use different unit operation like cooling, distillations, heat exchangers. So now this is how you need to do. So from key takeaways from this video is how to simulate a extractive distillation column, solvent recovery column, and how to use most effectively. In this video we have discussed about using a recycle block to recycle back the recovered solvent, so that we had only feed coming in, phenol, toluene going out, and similarly the T product, that is isooctane, that is going out. So these are this is the intended process that we want. It is sharing almost pure isooctane and almost pure toluene to the market, or we can ship this. This is the output of this process. We can ship it or use entire inside our plant. So this is how a complete flow sheet is simulated in a DWSIM. So now if you want to learn these about DWSIM and other flow sheets, please subscribe my channel. Thanks.